Imagine this, you're looking up at the night sky stargazing like people have done for thousands of years. You see distant twinkling lights, maybe even spot a shooting star streaking across the sky. But what if I told you that there's something monumental, something colossal that surrounds everything you see? Not just the Earth or the planets, but the entire solar system itself. A boundary so immense, it spans 1.5 light years in diameter. Yet no one has ever seen it. This is the story of the Oort Cloud, the greatest structure in our solar system that we've never directly observed. It's a cosmic ghost made of ancient icy remnants left over from the birth of the sun and planets. And although we can't see it with our eyes or telescopes, its presence is written in the icy trails of comets that occasionally grace our skies. Today we're going on a journey to the edge of our solar system and into the realm of pure speculation, brilliant science, and the human drive to understand what lies beyond. We'll explore how astronomers piece together this invisible puzzle, the real-life encounters that stirred its contents, and the implications of its vast, silent existence. Before we head out into the mysterious reaches, let's ground ourselves in the celestial geography we can observe. You've probably heard of the asteroid belt. It's a vast ring of rocky debris that lies between Mars and Jupiter, and it's essentially the leftover building material from when the solar system was forming. For some reason, Jupiter's gravity didn't allow this region to coalesce into a planet. Then there's the Kuiper belt farther out. Discovered and understood more thoroughly in the late 20th century, this ring of icy bodies lies just beyond Neptune and extends out to about 50 AU astronomical units. Pluto lives here along with other dwarf planets like Eris and Makemake. What's interesting about both belts is that their objects generally orbit the Sun in the same plane and direction as the planets. They're relatively neat and orderly planetary suburbs, if you will, but beyond them lies chaos. In 1950, Dutch astronomer John Oort noticed something strange about long-period comets. Unlike their short-period counterparts, which originate from the Kuiper belt and come back around every few decades or centuries, these long-period comets were unpredictable. They'd appear suddenly and then vanish often, not to return for tens of thousands or even millions of years. Not only that, but they came from every direction, not just from the plane of the solar system. That hinted at a source that wasn't a neat disk like the Kuiper belt. So Oort proposed a radical idea that there exists a spherical shell of icy objects far beyond Neptune, far beyond Pluto, even beyond the Kuiper belt. This shell might contain trillions of icy bodies, all loosely bound to our sun by gravity. Thus, the Oort Cloud was born not as a discovery, but as a hypothesis. This is where the beauty of science comes into play. We've never seen the Oort Cloud, not directly. It's simply too far away, too dim, and its components are too small to be observed with current telescopes. But indirect evidence gives us strong reason to believe it exists. Astronomers have traced the paths of hundreds of long-period comets and found that their aphelion, the point in their orbit furthest from the sun clusters, around 50,000 AU. That's roughly 7.5 trillion kilometers. These orbits are so eccentric, so long, and come from so many different angles that a spherical origin is the best explanation we have. To make this idea easier to digest, think of the solar system as a cozy house. The planets are the furniture, the Kuiper belt is your backyard garden, and the Oort Cloud is the distant fence so far out you can barely see it, but it's there. Let's pause for a moment to understand scale. 1 astronomical unit, or AU, is the average distance between the Earth and the Sun, about 150 million kilometers. Earth is at 1 AU, Jupiter sits around 5 AU, and Neptune at 30 AU. The Kuiper belt ends around 50 AU. The Oort Cloud, its inner edge begins at 2,000 AU and may stretch to 100,000 AU or more. Now here's the kicker. The nearest star system to us, Alpha Centauri, is about 270,000 AU away. That means the Oort Cloud could extend halfway to our closest stellar neighbor. That's not a wall, it's a moat. So how did it get there? The leading theory is that during the early days of our solar system, when the giant planets like Jupiter and Saturn were forming, their immense gravity slung smaller icy bodies out of the inner solar system. Many were ejected into interstellar space, but a significant number remained bound to the sun, caught in far distant orbits. Over billions of years, gravitational nudges from passing stars, interstellar clouds, and the galactic tide helped shape this scattered collection into the spherical shell we now call the Oort Cloud. In a way, it's like the attic of the solar system filled with old, forgotten leftovers from a chaotic youth. About 70,000 years ago, something extraordinary happened. A small binary star system known as Schultz's star passed through the outer reaches of the Oort Cloud. It came within about 52,000 AU of the wet, well inside the range of the cloud. Now, this wasn't a Hollywood-style cataclysm. Schultz's star was small, a red dwarf with a brown dwarf companion, and its gravitational influence was mild. But simulations suggest it may have nubbed some Oort Cloud objects from their quiet orbits, sending them on long journeys toward the inner solar system. It's a reminder that the cosmos is not a static place. Even now, the stars themselves can intrude upon our solar sanctuary. The Voyager 1 and Voyager 2 spacecraft launched in 1907 have traveled farther than any human-made objects. Voyager 2, for instance, is now more than 140 AU from the Sun. It has passed the heliopause, the boundary where the Sun's solar wind is no longer dominant. And yet it hasn't even reached the Oort Cloud. In fact, at its current speed, it won't get there for another 300 years. And crossing it, that could take 30,000 more. That's how vast the Oort Cloud is. Our greatest journeys so far haven't even reached the front door. In 2019, a telescope in Crimea spotted something unusual. A comet now named 2I by Borisov entered our solar system on a hyperbolic trajectory, meaning it wasn't coming back. It had originated from another star system. Its composition was strange higher levels of carbon monoxide than in most solar system comets, suggesting it formed in colder regions, possibly near a red dwarf. Its visit confirmed a long-held suspicion comets can and do come from outside. But it also added credibility to the Oort Cloud model. After all, if interstellar objects can visit us, surely our solar system must have similar messengers waiting to be dislodged. So why haven't we seen it? The answer is distance and light. Most Oort Cloud objects are no larger than mountains, let's say 10 kilometers across. The distance to the nearest ones is at least 450 million kilometers. That's like trying to spot a mosquito from across a football stadium, except the stadium is the size of the Earth. Unlike stars and galaxies, these icy chunks don't emit light, and they're too far to reflect much sunlight back toward us. Our best telescopes simply aren't sensitive enough. For now, the Oort Cloud remains invisible. Science often moves forward on the strength of indirect evidence. We don't always need to see something to believe it's real. Think about gravity or dark matter or even germs before microscopes. Likewise, while we haven't seen the Oort Cloud, we've seen its footprints. Long-period comets that come from nowhere. Patterns in their orbits. Simulations that match reality. The math holds up even if the light doesn't. Interestingly, scientists believe that other star systems might have Oort clouds too. If planetary formation is universal, then so is the ejection of debris. That means every star could be wrapped in its own ghostly halo of icy remnants. We're not alone in having a cold, silent wall surrounding us. We're just the first to imagine it. Let's bring this back to home. In '97, Comet Hale-Bopp streaked across the sky for months, visible even from cities. For many people, it was their first real encounter with a comet and a visceral reminder of the cosmos. That comet likely came from the Oort Cloud, nudged by forces we can't see on a journey that took millions of years. For indigenous peoples and ancient civilizations, comets were often seen as omens. From the Mayans to the Chinese, these icy visitors were part of cultural lore. It's poetic to think that their origins may trace back to the same mysterious cloud that we're only now beginning to understand. The Oort Cloud may never be seen in our lifetimes. It may remain a theoretical structure, a ghostly boundary that separates our solar system from interstellar space. But its influence is real. It sends us comets, holds our history, and defines the edge of what we can call home. It reminds us that there are still frontiers left to explore, not just out there in space, but in our understanding of the universe. The wall around our solar system isn't just made of ice, it's made of mystery. And that's what makes it beautiful. Who knows, maybe the next great discovery will be the first photograph of an Oort Cloud object. Or maybe we'll discover that what we imagined as a wall is actually a doorway.